Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled The Effect of the Planet X System on the Earth. Now the Planet X system is a system of dead stars and planets which moves from star system to star system, absorbing all the energy available in these systems and thus destroying them. Once all the energy has been drained by the Planet X system from a living star system, all the members of this system will be dead or energy depleted. This means that all the stars and planets of the once living system would have become stellar cores. The Planet X system is thus ever growing in size. And you may look at article 244 entitled Planet X System, Destroyer of Star Systems for more details. And here we see one of these stellar cores in the Sun's corona. This is one of the Planet X system objects. And these objects absorb energy from living celestial objects. That is, objects that are still generating energy in their core. So these stellar cores are in the Sun's corona. They're absorbing energy from the Sun. And as you can see, it's clearly a spherical object. We can see that it's striped. We can see that the stripes follow the contour of the object. That's why they are curved, because they are a spherical object. And we can usually see these stellar cores in sun-observing satellite images. And here we see another one. This one is about 4 times the size of the Earth, so it's very small compared with some other objects. This one, for example, is about half the size of the Sun. The size of the Sun is indicated by the black circle, and this is about half of that. So this is a huge object. It would be 5 times the size of Jupiter. And here we see some more of the smaller ones. This one's about half the size of Jupiter, but this one is dark. It still hasn't emitted light, hasn't started emitting light, and that means that it's a new arrival. Because after a while they absorb material from the Sun and they gain an atmosphere and start emitting light from that atmosphere. And this one we see here, the circular outline indicates there's another object there. There's the plasma connection it's making with the Sun, and this one is making a vortex type of connection with the Sun. You can see sort of in the shape of a vortex there. And so it's drawing matter from the Sun, but it's still dark, indicating that it's a new arrival. Now, living stars and planets generate energy through the mechanism of radioactive decay in the core. At formation, all celestial objects will have a certain amount of unstable nuclei, which by decaying into lighter nuclei release energy. This initial amount of unstable nuclei in a celestial object's core is like a reservoir of energy. It may also be visualized as a battery, which is fully charged at the beginning of the celestial object's life, but which runs down eventually. It can take billions of years for all the nuclei to decay and thus release the energy contained in them. But eventually the core will run low on nuclei that can still decay. And since the energy in the core is directly related to the strength of the gravitational interaction, an energy depleted object is not able to strongly attract its own particles and other objects. And this causes the object to expand in size. And here we see illustrated radioactive decay, where we start with a heavy nucleus, which then splits into 2 parts, which are lighter nuclei, and this process allows the release of a lot of energy, and a lot of it is directly radiation, and some of it is described as heat. But heat is actually in the form of photons. Heat is energy that particles have, which gives them the ability to vibrate or move. So, and it's actually photons or photon energy inside the particles that allows them to vibrate or move at high speed in response to that energy inside them. So heat is actually photons. Now, in Article 191, entitled The Photon Universe, it is all made out of light. I explain all that in detail. Now, the gravitational interaction has two main parts, which deeply affect what then happens to the object. One of the parts is the repulsion between protons and electrons, which causes celestial objects to have a positive inner core and a negative outer layer. When this interaction, which can be referred to as the charge separation part of the gravitational interaction, drops in strength, electrons move inwards towards the core, and thus the electric field or electric potential generated by the object drops, which causes it to lose the ability to emit light. It also loses its outer negative layer, which becomes neutrally charged instead of negatively charged. And this is explained in Article 184 entitled Stellar Core Evolution. And here we see one of the stellar cores that is attached to the Earth and it's drawing energy from the Earth. You can see there's a gaseous atmosphere around it from which it's emitting light, and we can see a long line here. It's obviously a connection that it's making with the Earth's atmosphere, and the fact that it's so bright means that there's light emission and ionization, and therefore an energy transformation going on here, because it's absorbing energy from the Earth, which then allows it to emit light. Now, so there are several, at least 3 Planet X system objects or stellar cores attached to the Earth, and the evidence for that is detailed in Article 243 entitled Earth hosting at least 3 Planet X system objects. And this object was scored by JFP in early March of 2018. And these objects are able to remain stationary with respect to their host object. We see them doing this in the sun's corona, and they do the same thing with the Earth. They may actually touch the Earth's atmosphere, actually come into the Earth's atmosphere, because they go into the sun's atmosphere, and then they make a matter connection. With that connection, it's like becoming a part of their host, and so they will rotate with the host. And in Article 227, entitled Stellar Cores Affecting Earth and Possible Connection to Volcanic Eruptions, I detail some of the evidence for this. Now, here we see that that's the same object we saw in the previous figure, but here it's in false color, and we can clearly see the amount of material around this object from which it is emitting light. It's gaseous material, but it's emitting light, so it's ionized. And this material obviously comes from the Earth. It's drawing material from the Earth, it's ionizing it and using it to emit light, but all the energy for all this light emission is coming from the Earth's core. And here is illustrated what occurs when objects, normal celestial objects, in this case, I think I was referring to an object that is a star that's emitting a large amount of light from its atmosphere. But the same thing will happen to planets, because stars and planets are basically the same thing. The only real difference is that stars generate a much higher electric field in their outer layers, which allows them to emit a lot of light and also have CMEs and a solar wind. Planets do not have CMEs or solar winds and do not produce nebula rings. Saturn does. So Saturn is more of a star than a planet. Now, what we see here is we start off when the object is young, it's able to generate a lot of energy in its core. it will then generate a gravitational field and an electric field as a result. So it will be positively charged in the interior, in the inner core, and it will be negatively charged on the outer layer. And then when it reaches, it gets close to the end of its life, when its energy in its core runs down, it doesn't have as much energy, but this is not the end yet. At this point, the potential difference drops, and it stops being able to emit light, because the potential difference across has to be strong enough for light emission to be possible. So if it's not high enough, then light emission will stop. And in the meantime, many years have passed, and over the years, the object will lose electrons. And then what we have is, at the end, eventually it won't even have any electrons in its outer layer. This layer will become neutral. And as you can see, the object also expands in size. And it does so because the gravitational force it is able to have decreases in strength. So that means it's not able to hold on to its own material as well as before. And that means the material, its outer layers, start moving outwards away from the core. And that causes it to expand in size. Eventually, it will actually lose most of its outer layers. And what will be left is a core, but expanded in size, and a few of the remaining layers around the core. And so the other important part of the gravitational attraction is the attraction between protons, which gives rise to the strong force, and the force which we know as gravity. When, as a result of energy depletion, the strength of the interaction drops, the object's ability to attract its own particles in its outer layer decreases, which causes the object to expand in size, as I've said already. Now, the object will also lose the ability to attract any of its satellites. So a star would lose its planets, and a planet will lose its moons. This object, which has now become a stellar core, will still retain a less positive but still positively charged inner core, and will thus be attracted via the electrostatic interaction to objects which still have an outer negative layer and are thus still generating energy in their cores. So this is actually what has brought the stellar cores into the solar system. They were attracted to the sun's negative layer. And also the other the planets in the solar system, they're not as large as the sun. They will not attract as many stellar cores, but they still have a negative outer layer. They still have a core that's generating energy. So they will attract stellar cores as well. Now, stellar cores, because their matter is so depleted in energy, absorb any energy they come across. They absorb radiation or photons, and they absorb matter which contains energy in the form of photons. It is these photons which are responsible for whatever strength the gravitational interaction is able to have. So these objects absorb light and matter. In the meantime, the object which becomes the host of the stellar core and is losing energy starts to lose more energy than it is generating, which causes the rate of radioactive decay in its core to increase. And you may look at Article 240 entitled Planet X System, Effect on Radioactive Decay Rate and Heating of Planets. This means that it starts running through its energy reservoir faster. In the meantime, the stellar core gains enough energy to start emitting light, but all at the expense of its host. As more and more stellar cores arrive and start also depleting the host, it loses energy more and more rapidly, and thus the radioactive decay rate keeps increasing in response until the host runs out of energy and becomes a stellar core itself. It then moves with the other stellar cores in the direction of another host that is still alive and thus generating energy in its core. But before the host reaches the point when it too turns into a stellar core, its surface temperature would increase because more energy is arriving at or moving through its surface as a result of the increased rate of energy generation in the core. The host would also start expanding as the strength of the attraction on its own outer layers decreases. This causes the Earth to expand and its outer layers to crack open so that fissures and sinkholes appear. But the gravitational decline is likely to be unstable, so that different regions are likely to experience a greater drop in the attraction to the core than others, and this will lead to sea levels varying wildly over different regions, thus explaining the ocean recession events the Earth has been experiencing. In addition, since the Earth has a hot liquid layer of magma, the breaking up of the surface causes the magma to more easily reach the surface, which will lead to intense and possibly never-ending volcanic eruptions, which will only increase in severity over time. Eventually, the Earth's crust will be completely broken up and vast regions will be covered in continuously flowing lava. And you see the results of what's occurring here, because the Earth's surface is expanding, because the whole planet is expanding, because the gravitational field it is able to maintain is decreasing. Then the surface just breaks. Just imagine, you have a spherical solid sphere and it starts expanding. And what happens, because it's solid, is it has to crack open in order to expand. That's the only way it's going to happen. So this means that the Earth's surface starts cracking and fissuring, as we see here. And this is why this is happening all over the world. And then as the fissures open up, it makes a way for a magma to come from inside the Earth all the way to the surface. And more magma will find its way to the surface. So as the stellar cores absorb energy, the strength of the gravitational attraction they are able to exert on a planet like Earth will increase to the point that crustal displacements and thus pole shifts are likely to occur. And these will most likely occur repeatedly, because the stellar cores do not leave until all of the planet's energy is gone, by which time all its rocky surface will be completely destroyed. Now, at the end of the process, the celestial objects lose most of their outer layers of material, and only the solid core and a thin layer around the core will be left. So what will occur to Earth? Well, Earth seems to have attracted at least 3 stellar cores, and it will most likely attract more as time goes on. Earth has experienced sinkholes for many years now, and has also experienced unprecedented ocean recession events. All these indicate that Earth's gravity is decreasing, and doing so in an unstable manner. The fact that the Hawaiian volcanic eruption shows no sign of stopping, but seems to be getting continuously worse, is an indication that Earth's deterioration is now reaching an advanced stage, which can only worsen as time progresses. The next step would most likely be more volcanoes starting to erupt, and maybe a crustal displacement with worldwide mega earthquakes occurring as a result. Unending volcanic eruptions will eventually lead to parts of volcanic islands undergoing volcanic activity, to cause slips or collapses into the ocean, which then generates mega tsunamis. And you may look at Article 237 entitled Hawaiian Island and Mega Tsunamis. And here we see illustrated how a small object exerting a small gravitational force on a larger object, say a moon, but coming very close to that object through tidal forces causes the ocean to pile up underneath it and on the other side of the earth. It also causes a tidal wave. So that would be a tidal wave. And this is a tidal wave in the Earth's inner liquid layer. So that will be in the outer core. And as those tidal wave moves around the planet, then it causes the upper solid part of the earth to disconnect from the core and to move freely with respect to the core, so that what we end up with is the poles and everything else on the surface being in different positions with respect to the core. So that's why it's often called a pole shift. But it's actually a crustal displacement. The crust is displaced with respect to the core. Since the stellar cores attached to the Earth cause more energy to be generated in the Earth's interior, all of Earth's layers will be more energized, including the ionosphere, which will lead to increased severity of storm systems and increased lightning. These are all events that we have been experiencing more and more for some years now. So here we see lightning, and we know we've seen more and more lightning occurring, sometimes lightning occurring without rain, which is strange. And this is due to our ionosphere being more energized than ever before because of more energy coming out from the interior of the Earth and going through all of Earth's layers and causing every layer to be more energized than before, including the ionosphere. So in conclusion, the Planet X system will have a very serious and disastrous effect on the Earth. Their effects are likely to keep on increasing as time progresses. Some of these effects are the appearance or incidence of fissures, sinkholes, volcanic eruptions, crustal displacements, earthquakes, and increased lightning. The Earth's surface and oceans will also increase in temperature as unstable nuclei release more energy due to an increased rate of radioactive decay, which causes more heat to be produced in the core. This heat flows outwards outwards from the core and moves through all of the Earth's layer. And this in turn will heat the surface of the Earth, atmosphere, and oceans, and it will also heat the magma in the Earth's interior, and thus also greatly contribute to the increase in volcanic eruptions. And this is Dr. Claudia Albers, Planet X physicist. Thank you for watching.